A stone is dropped from the edge of a roof and hits the ground with a velocity of negative 140 feet per second. How high in feet is the roof? Note the acceleration of an object due to Earth's gravity is negative 32 feet per second squared. Okay, so to do this problem, we got to remember that S, which we use for position, I don't know why, it's height, same thing, height or S, whatever. And then velocity, velocity or speed. And then A, which is acceleration. The relationship here is this is the derivative. The derivative of position is velocity, and the derivative of velocity is acceleration, and vice versa. The antiderivative of acceleration is velocity, and the antiderivative of velocity goes back to position. Okay, so what are they giving us? They're saying a stone is dropped from the edge of a roof and hits the ground with a velocity of negative 140. So they're saying feet per second. How high in feet is the roof? Okay, well, let's start with this statement. Acceleration is negative 32. So we'll start right there. So we'll say, okay, acceleration is negative 32. And then, so we're at acceleration right now. We want to go back to velocity. So we got to do the anti-derivative. So I'll do that. Anti will be velocity. And what's the anti-derivative of negative 32? It's negative 32t, right? Because the derivative will go back to negative 32. So the anti is minus 32t plus constant 1. Because there could be any number. Constant means any number, not a letter, no t's, but any number like a 5, a 7, whatever, could be added because the derivative will go back to nothing. So any number could be out there. And the derivative of this, minus 32t plus any number, say like 7, will go back to minus 32. So then it is properly considered the antiderivative. Okay, and now they tell us that it hits the ground with velocity minus 140. Yeah, we don't know. Let's just keep going. We don't know what that is right now. So let's do another anti. So anti number 2. Anti. So we're going now we went from acceleration to velocity, right? From acceleration to velocity, and now we're doing an anti to position. So this will be position. And we'll do the anti. And then what's that going to be? Now remember how the anti rule works? You have x to the n, the antiderivative, the opposite derivative. You do the opposite of the derivative. You, instead of subtracting 1 from the power, you add 1 to the power. Instead of multiplying by that number in the front, you divide by that number in the front or multiply by 1 over it. Same thing. So I take that minus 32 and I take that 1 power and I'm going to add 1 to it. Make it t squared. I'm going to divide by 2 plus C1t. Now that's C1t. Why? Because again, the derivative of C1t will just go right back to C1. So that means C1t is the anti. And finally, plus constant 2. So you see what I'm saying there? I'm saying if this could be any number here, this could be like, C1t plus 3 or whatever. The derivative will go back to C1 and go to nothing. So C1t plus any constant, derivative will go back to C1 and then nothing. All right, let me plug in now. It says, oh, wait a minute. Yeah. Um, yeah, sorry, I made one small mistake. We know that C1 is 0. Here's why we know. Yeah, I didn't see that. The stone is dropped from the edge of a roof. So that means the velocity at time 0 is 0. Why? Well, if you drop something, you're not throwing it down. So they didn't stand up on the roof and throw it downward, giving it a starting velocity downward. No, they dropped it, which means you just let go of it. So it had no, when you first, the instant, right at time 0, right at the instant you let go of it, it had no velocity, no speed. You didn't throw it down or throw it up. You dropped it. You let go of it. So at the starting time, it had no velocity. So that means right over here, I should have done v of 0, which is going to be minus 32 times 0 plus C1 equals 0. And this is just 0. That means C1 is 0. So now we know C1 is 0. So we can drop out that C1. C1 is 0. And so this just becomes constant 2. There we go. Okay, now we're good. So that's just constant 2, right? Because the derivative of constant 2 would still go back to 0. Any number still go back to 0. Okay, so I didn't think about that. Now, let's clean that up a little bit. We have the position function is minus 16t squared plus c2. We don't know c2. Now, what do we know? We know it hits the ground with a velocity of minus 140. Hits the ground with a velocity of minus 140. So let's think about what that means. When it hits the ground, S equals 0. That's the height. Remember that the S is the height, position, called it H or S up there. It's the position, the height. So when the stone hits the ground, it has a height of 0. So if I take this equation then and I put in 0 for S, right? I can find the time. Find T, time, when S equals 0, or it hits the ground. I got to solve this equation. So I'm going to bump this to the other side. Positive 16t squared is C2. Okay, and now divide by 16. C2 over 16. And square root it. Square root it. Square root it. We don't need, normally go up and down the ladder, but there's no such thing as negative time. So therefore, the time is, and I'm going to make it square root of C2 over 4, right? Square root of 16 on the bottom is just 4. That is the time when the stone hits the ground. So that's the time when the stone hits the ground. Okay, so what? At that t equals square root of C2 over 4 time, the velocity when it hits the ground is what they tell me. They told me it hits the ground with a velocity negative 140. So at that time, which is the time when it hits the ground, the velocity is negative 140. So I grab the velocity function now. Where's the velocity function? Right here. So minus 32t plus 0, so just minus 32t. That's the velocity function. Equals minus 140 at that time. So if I grab that time, plug it in there. So minus 32 times root of t2 over 4 equals minus 140. I can solve for C2 now. Does that make sense what I'm doing? It's a little tricky, isn't it? Came up here and I said, okay, I took the position. They said, when it hits the ground, find the time. So I put in a 0 for the position, solve for t. There's the t, which has a constant in it. There's the time when the stone hits the ground. And at that time, the velocity, this equation, equals negative 140. So plug in that time right there. And velocity is 140. So now let's solve this equation. So I'm going to divide both sides by minus 32, put on both, and I get the square root C2 over 4 is, I'm just going to make it positive. Two negatives make it positive. I'll simplify it in a minute. Multiply both sides by 4, right? And I get the square root of C2 is 140 over 32 times 4. And then, how do you finish getting C2 alone? Second power both sides, huh? So C2 equals, so I'm going to second power that 140 over 32 times 4. 140 over 32 times 4. So parentheses, 40 over square. 140 over 32 times 4 squared. Is that right? Did I do that right? It's kind of a weird number. 32 times 4, the whole thing squared. 40 over 32 times 140 over 32. Oh, no, the times 4 is in the front. Aha. Okay. What am I doing? I'm getting it wrong there. So, times 4. There we go. 306.25. That's better. 306.25. 306.25. So, 306.25. So now we've got the C2. So we found C2. So what? Well, that means we can now answer their final question, which is what? How high is the roof? How high is the roof? Well, let's go back. High is the position equation. Let's grab the position equation, which is right here. Minus 16t squared plus C2. So the position equation, minus 16t squared plus C2. Now we know that the C2 is 306.25, right? We found that. Okay, so what? But how do we find out how high is the roof? How high is the roof? Well, we need to find S when t equals 0. Why? Because remember what they did at the start? At the start, at time 0, they dropped from the edge of the roof. So S of 0 is the height of the roof, right? At time 0, how high was that rock at time 0, at the start of this situation? It was on the roof. And right then, at time 0, the person dropped it. They let go of it. So right at that instant, right at time 0, the position, which is the height, was the height of the whole roof. It was up on the roof at time 0. So we go, oh, so just take t equals 0, plug it in. That's pretty easy math. Minus 16 times 0 squared plus 306.25. So clearly S is, 306.25. That's the height of the roof. 306.25 feet. 306.25 feet. There we go. Interesting, huh? So this is a tricky problem. So from just knowing the velocity when it hits the ground and knowing that it was dropped from the edge of a roof, we can figure out how tall that roof is based on how hard it hit the ground or how fast it hit the ground. So what did we do? We took the acceleration equation, we did the antiderivative, got the velocity equation, had C1, and then I realized the velocity at time 0 was 0 because they just dropped it. They didn't throw it down. No velocity at the start. So I meant C1 is 0, C1 dropped out. Then I did an antiderivative again, went to the position equation. Got this, and it's minus 16t squared plus C2. Then to find C2, I said, well, when it hits the ground, that's when the height is 0. S is 0. I put in a 0 for height. And I found the t. I solved for t. There's the t, the time when it hits the ground. And then I plug that in to the velocity equation at any time. So, well, at that time, the velocity is negative 140. So I was able to solve that equation for C2. Then I went back to the position equation, put that in. And I want to know how high the roof is. It's the position at time 0. Put in a 0. It's just that number, 06.25. That is pretty tricky. And so there we go.